Okay, let's look at how to draw a basic Lewis structure. Okay, so the first thing that you want to do is, well, first we need a chemical formula. So let's say we had H2O. All right, so the first thing is you need to add up the valence electrons in the molecule. So if you look up, hydrogen is in group 1A, so it has one valence electrons, but we have two hydrogens. Okay, so 2 times 1 is 2 valence electrons for hydrogen, and oxygen is in group 6A, so it has 6 valence electrons. So 2 plus 6 equals 8 valence electrons. So when we draw our Lewis structure, we have to show 8 electrons in our drawing. So the first thing is to usually put the least electronegative atom in the middle, but sometimes doesn't always work out that way. But in general, that's what you do. But hydrogen always goes on the ends. Carbon always goes in the middle when you get to a carbon one. So anyway, but let me start with that. So let's put oxygen in the middle because hydrogen's always on the end. And we're going to, all right? And so then step 2 is connect all atoms with a single bond. So a bond is a dashed line. The dashed line represents 2 electrons. So like if you have oxygen here, it has 6 valence electrons. Well, when we have a hydrogen, when we draw this line, we're talking about 2 electrons that are being shared. So that's what that line represents. All right? And so we're going to connect everything with a single bond. All right? Now we're going to add lone pairs of electrons until the octet rule is satisfied. The octet rule is all atoms need 8 electrons around them except hydrogen. It only gets 2. So whenever you bond hydrogen, these 2 electrons count for 2 around hydrogen, even though one of them is from oxygen. So hydrogen's good. Whenever you make a single bond with hydrogen, that's all you can do. All right, so this hydrogen's good, this hydrogen's good, but oxygen needs 8 electrons around it. Right now it has 2, 4, 2, 4. So we add a lone pair, 6, and then we add another lone pair, 8. Now oxygen has 2, 4, 6, 8. Its octet rule is satisfied. Okay, step 4, we're going to count the electrons in our drawing. So we have 2, 4, 6, 8, and we're going to see if that matches what we started with at the beginning. So our drawing matches the electrons that we counted in step 1. And when you've done that, that means you're good. You don't need to do anything else. This one's okay. All right, let's try another one here. So let's see here. So, all right, so let's do another one here, and let's do this one right here. NH3. All right, now we'll start with step 1. We'll count up the valence electrons. Nitrogen has 5. It's in group 5A. And hydrogen has 1, but there's 3 there, so 5 plus 3 equals 8 valence electrons. So hydrogen always goes on the end, so we're going to put nitrogen in the middle and surround it with 3 hydrogens. Okay, then we're going to go through and we're going to add up the valence, or add lone pairs until everything has the octet rule satisfied. Remember, hydrogen's octet rule is satisfied when it makes a single bond. But nitrogen needs 8, and it has 2, 4, 6, so we have to add a lone pair. Then we count to make sure that it matches the number that we came up with in step 1. So let's count. 2, 4, 6, 8. Okay, that matches, so this one's okay. All right, let's try another one here. All right, so here's one, CO2. All right, so anyway, let's add up the valence electrons. Step 1. Carbon has 4, it's in group 4A. Carbon has 6, or oxygen has 6, but there's 2 oxygens, so 6 and 6 is 12, 13, 14, 15, 16. So we got 16 valence electrons. Okay, now one rule about carbon. Carbon always goes in the middle, so put carbon in the middle, put the oxygens on the ends. Okay, now we're going to do step 3. We're going to add lone pairs until everything has 8. 2, 4, 6, so that's 2, 4, 6, 8. That's good for that oxygen. Okay, let's do this oxygen. 2, 4, 6, and 8. Now we got to do carbon. 2, 4. So now 2, 4, 6, 8. Everything has 8. If you count, everything has 8 around it. Now let's count to see if it equals our 16 number. So we got 6 there, 12, 14, 16, 18, 20. Uh-oh. Okay, our picture is showing 20 right now. So when it shows 20, you need to reduce until you get 20. And here's how you do that. So the way that you will reduce is by adding what's called a double bond and then a triple bond. So what you're going to do first is always try a double bond in spots before you try a triple. So what we're going to do is we're going to add a double bond there. Alright, now that counts as 2, 4 electrons there. So when you add a double bond, you have to erase lone pairs so that you maintain the octet rule. So now I'm going to count around oxygen. 2, 4, 6, 8, 10. That's too many. Oxygen only needs 8 around it. So I'm going to erase a lone pair. And now if I count 2, 4, 6, 8, oxygen has 8 around it. It's good. Let's look at the carbon over here. Carbon has 2, 4, 6, 8, 10. Too many. So I'm going to erase a lone pair off this carbon to keep 8. I'm just trying to keep 8 around everything. Now everything has 8 around it, so let's count. 2, 4, 6, 8, 10, 12, 14, 16, 18. Oh, still too many. So if that's still too many, you try another double bond. So I'm going to put a double bond right there, and then I'm going to have to erase because as you can see around the carbon 2, 4, 6, 8, 10 now. So I have to erase, and now that makes 8 around carbon. Now this oxygen 2, 4, 6, 8, 10, it has 10 around it. It only needs 8, so I need to erase a lone pair. Now if you count 2, 4, 6, 8, everything has 8 around it. Let's see if it equals 16. 2, 4, 6, 8, 10, 12, 14, 16. Yes, it equals that. So we're done with that one. All right. Let's try one more here. All right. So this one is going to be one that you'll see it's going to have a triple bond in it. So HCN. All right. So what we'll do is we'll start off and we'll first valence electrons. So there's one there. Carbon has 4, nitrogen has 5. So that's going to equal 10 electrons. So we'll connect everything with a single bond. Okay, carbon always goes in the middle. Okay, we're going to add lone pairs until everything has its octet satisfied. Remember, don't ever put lone pairs on hydrogen because one bond satisfies hydrogen. Okay, so, but everything else, you're going to add lone pairs until everything has 8. So nitrogen has 8, carbon has 8, hydrogen's good with 2. Now let's count. 2, 4, 6, 8, 10, 12, 14. Okay, my picture is showing 14. Whenever you add a double or a triple bond, one bond will reduce by 2 electrons. Okay, so we need to reduce 4, so that kind of means we're going to have to do a triple bond here, but let me show you. All right. So right now I need to reduce from 14, I need to get to 10. So first I'm going to try a double bond. And when I try a double bond, I have to erase electrons until I'm maintaining the octet rule around everything. So I'm going to erase this pair right here. All right, now that has 2, 4, 6, 8 around nitrogen, but I got 10 around carbon, so I need to erase a pair there. All right. Now, if I count 2, 4, 6, 8, 10, 12, that's still not 10. I need to reduce by 2 more. So I need to add a triple bond. Now, one thing, you can never do a double bond or triple bond with hydrogen. Hydrogen forms one bond, it never doubles or triple bonds. Okay, so the only place to reduce by 2 more electrons would be to try a triple bond here with the nitrogen. Okay, and carbon. But now you got to reduce electrons to maintain the octet, because right now we got 2, 4, 6, 8, 10, and we only need 8. So I'm going to erase another lone pair. There, that makes 8 around nitrogen, but carbon has 2, 4, 6, 8, 10. That's 2 too many. So I'm going to erase this lone pair here. Now, if I count 2, 4, 6, 8, 10, that's what I got. That's what I was supposed to get. Everything has the octet rule satisfied, so it's good to go. That's the right answer right there. Okay, that's it.